Hello, welcome back. I'm so excited for today's lesson because today we're going to become computer detectives. Seriously, by the end of the session, you are going to understand something that most grown-ups don't even think about. How does a computer, this little box that has no brain, no eyes, no feelings, actually figure out how to do things? Today's big mission is written right here at the bottom of the screen. How do computers solve problems? I want you to keep that question in your head the entire time we're together today, because I promise you, by the time we get to the end, you are going to be able to answer it better than almost any adult you know. This is week 4 of Byte Force, and it's all about algorithms and computational thinking. Those are big, fancy words, I know. Don't worry, we're going to break down every single one of them down together, piece by piece, step by step. Let's get started. Before we jump into today's new stuff, I want to warm up our brains a little bit. Here's a question on your screen. What's something you followed step by step today, like a recipe, game rules, or directions? Take a second and think about your whole day so far. Did you follow a set of steps to get ready this morning? Did you follow the rules of a game at recess? Did someone give you directions to get somewhere? I put a few examples up on the screen to help you think. Brushing your teeth, following a recipe, playing a video game, getting dressed. Every single one of these things, and I mean every single one, is actually a set of ordered steps. You probably didn't even realize it, but you follow step by step instructions dozens of times every single day without even thinking about it. Here's the cool part. That's exactly what we're going to be talking about today. Because guess what? Computers do the exact same thing. They just need us to write those steps down super, super clearly. Keep that thought in your back pocket because we're coming back to it. Okay, before we move forward, let's rewind the clock back to last week. Does anyone remember what we talked about? Last week's big question was, how do engineers solve problems? Let's remind ourselves of a few big ideas. First, engineers solve real world problems by designing things like bridges, robots, and even backpacks. Second, engineers plan first before they start building, so their designs actually work well and they don't waste materials putting something together wrong. And third, engineers improve their designs again and again. They're not afraid of mistakes. Mistakes actually help them to learn exactly what they need to be fixed. Hold on to that idea of improving again and again because it's going to come back in a big way today when we talk about something called debugging. Engineers and computer science actually have a lot in common. You're about to see why. Let's do a super quick lightning round through the 6 steps of the engineering design process because this is going to connect directly to what we're learning today. Step 1 is ask. What is the problem we actually need to solve? Step 2 is imagine. Brainstorm as many possible ideas as you can, even wild ones. Step 3 is the plan. Pick your best idea and map it out before you touch a single material. Step 4 is create. Actually build a prototype, a first try at your design. Step 5 is test. Try it out for real. Does it actually work the way you hope? And step 6 is improve. Fix whatever didn't work, and then you guessed it again. You go right back and try it again. That's why the little arrow icon at the top is shaped like a circle, because this whole process is a loop. Engineers repeat this cycle again and again, and there's actually a special word for it. It's called iteration. Say that with me. Iteration. It's just doing something over and over, getting a little bit better each time. Today, we're going to meet a very close cousin of this process, something computer science use called an algorithm. Let's go find out what that means. Take a look at these 5 words on your screen: computational thinking, algorithm, sequence, flowchart, and debugging. I'm not going to lie, these are five big, chunky vocabulary words. If I ask you right now what every single one of these means, you might not be totally sure yet, and that is 100% okay. That is exactly why we're here. Here's my promise to you. By the time this lesson is over, you are going to know exactly what every single one of these words mean, and you're going to be able to use them correctly. In fact, at the end of this class, I'm going to quiz you on a few of these. So keep your ears open. Let's start unlocking these words one at a time. Here it is again. Our big question for the entire day, front and center. How do computers solve problems? Think about it for a second. A computer isn't alive. It doesn't have a brain like you do. It can't figure things out the way you can when you're stuck on a puzzle. So how in the world does a computer know how to open an app or play a song or beat for you in the video game? I love hearing your guesses, and honestly, some of you all are. Yo, I'm just gonna stop, bro. This is terrible. I quit, bro. What is this?